Mwah. Hello. Wow, I forgot to say I was skipping yesterday because of the Super Bowl. I had plans. But today, gonna be juicy. Hold on, let me get my phone. I dropped my armrest. My armrest isn't attached to my office chair. It's a long story. Actually, it's not a long story. We were playing League of Legends on stream and I tore my armrest off my chair. Now, I'm not a toxic player, but I'm just saying that Malphite, all right? Hold on, let me boot up a couple more things here. I gotta set up my phone so I can see chat. So I gotta move this over here, mute you. Put this over here, make sure the music's not too loud. It's fine. I think it is. Make the screen smaller. I don't know why it's so big. Make it thinner. Don't know why it's so wide. Move it over here. Make it taller so I don't cry. Okay, move that over there. Done. Now we boot up another window. Make this lower quality so my internet doesn't hate me. Put this over here. Mute you. You're set at low quality. Okay. I think... Are we more set up now? I think we are set up. I think I'm ready. Let me just take a drink of water. Oh, I missed you guys. It's been a whole day. Code Toil, hello. How you doing? How you doing, Peter, Code Toil? Wait, do Europeans know that nursery rhyme? Peter, Cottontail, walking down the bunny trail. Hippity hoppity, Easter's on its way. Okay, so here's what we're gonna accomplish today. We're gonna go freaking nice background. We're gonna go freaking rapid fire through this program, okay? I am tired of rectangles, okay? As soon as we get rotated rectangles, as soon as we get our rectangles rotated, what we're gonna be doing is we're not even gonna do rectangle collision. We're just gonna do point in rectangle collision, which is so indescribably easier to program than rectangle collision. And I don't need that. I don't need rectangle collision in this specific program. So we're not going to do it. That'll be the next project maybe. But for now, we're just going to do point in rectangle checks on everything. It's fine. All right. So first things first, this disaster. Okay. So where were we at? I'm trying to remember. The program ran. Beautiful. I crashed it. Beautiful. Okay, what happened? So we have bullets. They shoot, but the rectangles are kind of cattywampus. My guess is, and this is just a guess, our rotation point is not being translated correctly. So let's quickly check that. We'll just follow all the creation of every point. So under pellet, we have a rotation point whose X and Y value is the rendered rectangle size, width and height divided by 2. Now, I don't think that's a good starting place. I think it should be bullet size X plus bullet width divided by 2. I think that's better. Now, it's not really going to solve our problem, but at the very least, it'll start always where we want it to. Plus. And I think that'll be a good little compromise for now. So now at least the bullet always, the collision rectangle always spawns where it needs to. So now, what are we going to do? We are going to go back to bullets. Oh, I'm gonna lurk. I'll see you later. Well, not see you later. Have fun lurking. Listen, I'm a third monitor streamer, but one day I'll make it to your second monitor, all right? And I'm gonna be happy at that point. All right. So what are we doing today? We are gonna check to see if we're actually moving the rotation point correctly. So every frame, when we call move, we set position, which translates the rectangle, and all of collision changes. Now, I'm debating about whether or not we do that before or after we rotate the point or move the rotation point. I think we do it after, because I don't know how comfortable I feel. Well, I guess the question is, what are we doing first? Are we moving the rotation point forward, or are we Do we even need to move the rotation point? I guess that's the question. We must, right? Hold on, let's just delete that real quick. We don't. So the rotation point only matters at bullet spawn. Okay, that's nice to know. I don't think, unless I guess if we want changing collision, like collision boxes mid-flight, that would matter. Yara, hello. Hope you enjoyed the Super Bowl. So we don't need to move the rotation point because that only matters at object spawning, because we set the collision angle with that point. Now the problem is we still have issues with it not being rotated correctly. Specifically this bullet on the ship, the one that's shooting right. Now they do stack on each other, so it's fine, but that's kind of an issue right there. I'm debating in my head how we're gonna do that. I almost want to try when we rotate to just, I almost think that we almost got something backwards. It's really hard to describe, but I think this is correct. Yeah, because it's not 1. It's X value times cosine angle minus Y value times sine angle. This is like trigonometry matrices. Is that what a good way to describe it is? I think this is correct. Wait, is this 180 divided by m pi? Oh my god, is that the issue? To turn into radians, I think it's divided by, I think it's 180 divided by m pi, isn't it? Oh no, was that the issue the whole time? No, in fact, it's significantly worse. Okay. So this does seem more correct. It seems like I do know for a fact the rotation point is exactly in the center of the rendered rectangle. The angle applies to the rendered rectangle, the collision rectangle though. Because we apply angle, yeah, float angle. So it is applied at the same time. When we call the attack, we're setting the velocity, we're setting the angle of the bullet, we're setting the position X, Y. Maybe what we do is instead of setting the position first, we set the collision angle first. Maybe that's the difference? No, in fact, it has the exact same effect. Okay, so it doesn't matter when we call that, huh? Doesn't matter when we call that. We know this is correct because the bullet always faces where we want it to, huh? In fact, I'm going to say this whole thing is correct as is. This is where we first get our angle. So I guess let's follow the angle and see how it applies to the collision rectangle to make sure we do this right. So anytime we call an attack or make an attack struct, this is where the angle is actually given. This angle is not the same angle that applies to individual bullets, but rather it's the arc of the shot we're shooting with. So the only one we've made is Nova, which is 360 degrees. So the idea is if I want like a wave of like 50 degrees, I can call the attack struct. Then we do this function, which is calling the attack. We give it the bullet we want to shoot, the number of projectiles, why do we give it the bullet object? Oh, we have to in order to push it back on the thing. So the idea here is that we are taking a vector here and we are pushing back on the list of the new bullet we've spawned. And the idea here is that this list will be the vector that contains all bullets to be rendered for the frame. That's why this exists. So every frame we call attack, or every 10 frames or something. And every sassy fajita, hello. And every 10 frames we do this call attack function, okay? So that's why this vector exists. So that way we can have a vector of all bullets to be rendered for the frame. So there's time to like buffer it, or basically, right? So render the whole vector. Anything on the vector gets rendered. Perfect. And then we have a we have an SDL floating point. This is the position of the bullet as XY coordinates, which is its position after taking into account velocity. So if it's going to be going at basically like a 45-degree direction, the position is where the bullet's going to be facing to go in that direction. At this point, the only way we programmed it is wherever the bullet's facing, that is where it's going to be going. Then we have a float temp angle, which is equal to M angle divided by projectiles. So 360 is divided by 5. That's basically, we're going to be dividing every arc, every attack angle by the number of projectiles we want to shoot. Then we have a set angle equals temp angle. So now we have ways of playing with the degrees without actually messing around with the original M angle of the object. So now we have our for loop. So this for loop only runs as many times as we have projectiles in the loop. Then we make the temp angle equal to this multiplied by the number of projectiles. The idea here is that when we shoot out a nova of 360 degrees by 6 bullets, basically every 60 degrees we're going to be creating a new temp angle, and that's how we divide the 360 degrees by the number of projectiles. Then we have our first float value, which is the x velocity, and then we have our second float value, which is y velocity. This is 1 times the cosine of temp angle times m pi divided by 180. This m pi divided by 180, this is just radians. We're going from degree land of 60 degrees to radians. So this is 60 turned into radians. Then you're finding the cosine of that, multiplying it by 1. Sorry, just to be clear, 1 is like the amount of distance traveled, right? This is the velocity of the bullet. We could actually change it where call attack can also input the velocity of the bullet. That is something we could change. This is what would change. So if I wanted a bullet to go on an arc, these values would be what I would change. Right now it's very linear, so 1x, 1y, but I could easily make that like another trigonometry function and we can go into an arc. That's how you would change that. Brownie man, hello. Welcome to the final Let's Play Around with Rectangles stream. Bullet set velocity x and y. So let's see what we do with this. We have these two values. This is the direction it's going in. Then we're going to set velocity. So what does set velocity do? Set velocity makes it so the velocity and y velocity, x and y velocity of the bullet object is set to these two speed values we give it. Okay. Then set angle. So set angle calls the angle of the bullet, meaning that those are speed, not arc. Well, careful, what's up? Those are speeds, but they can also be arcs, correct? Because while they are 1 and 1, I could easily make that like a function that like gives like a variable y value and keeping the x value the same, which is an arc, right? I do it in a bit of a different way. By the way, I own my own small rectangle rotation test program if you want to take a look at it. Sassy Fajita, if we don't figure this out in like the next 30 minutes to an hour, then I will probably ask for that, but we're going to be done with rectangles today. I am so tired of rotating rectangles. Once we're done with this, we're going to change the collision rectangle of the hero to a bullet point, and that bullet point will be point in rectangle collision check, and that's all we're doing. We're done with it, okay? At that point, we're moving on. You need an initial angle offset for arch? Well, anyway, we're not messing with it now. That's as far as I know, but we can play with it later. At any point, though, I could make this call attack function also require a velocity, and this velocity can change these two values. That's all I'm getting at, really. Now we have set position. The X and Y set position of bullet. What does that do? Set position changes the, oh, wait, sorry. Angle. Angle changes a lot, so we should talk about this. We set angle first. So the angle of the bullet, of that instance of bullet, and this matters, is equal to the inverse tangent of velocity x, comma, 0 minus velocity y, so it's a negative y velocity, multiplied by turning it into radians. So the question is... Oh, thank you, Fokai. Is that Fokai or Focal? I can't read from here. It's like a distant, it's like a distant text. 9874 though, cute. Thank you for following, I appreciate it. I don't know how you found me and followed me that quick, but thank you. As if a developer can decide when the done with the feature, we'll figure it out. So this set angle always has to be set before we change any collision angles, because set angle sets the angle of the bullet, which is equal to the inverse tangent, yada yada, right? So now we have the angle of this bullet object of that part of the vector done. Then we set the position, and all that does is set the rendered X and Y rectangle, and then translates the collision box. Should that be there? Interesting. So that set position doesn't just set the position of X and Y, it also sets the position of the collision box. Then we set the collision angle, which is this guy. This also takes angle, which is gonna be already changed for that instance. The rotation point is at the center of the rendered bullet. Not necessarily, though. Ooh, not necessarily. Because we were calling move after that. Ooh, you know what? Let's do that here. Rotation point dot x is equal to m render rect dot x plus m. I wonder if that was the issue, because we were changing the dot width divided by 2. I wonder if that was the issue, because we were changing the rotation point in the move function, and I thought that was good enough, but that's not actually it, is it? It should be changed here, and then we use it immediately. So m render rect underscore dot height divided by 2. There should be an underscore. Okay, let's see if that works. Huh. Well, that didn't do anything, but okay, sure. Okay. Then we push back the bullet and then it gets rendered. So where are we goofing here? Honestly, it might be the rotation function. Katybug, hello, how's it going? We just started stream. Got a 15 some odd viewers here, doing pretty well. I might be because I didn't stream yesterday, so people are just thirsty for the goo boy. Chat, what are you doing at the bottom of the screen? How do you guys even get down there? Get up in your corner, chat. There you go. You need initial angle offset for arc. Okay, well, we haven't done that before, so I'm not gonna touch it right now, all right? I'm gonna take my curly rectangles and then we'll call it good. Yeah, once we figured out how to rotate those rectangles correctly, we're ready to just move on from collision. Holy cow. People weren't kidding. Collision takes forever in video games. Jeez. It's going great. We're almost to the point where we can actually design the video game and not just do the engine. People weren't kidding, though. I am, what am I, 37 streams in times, we'll be generous and say 2.5 hours per stream. Because I get distracted with streaming. 92.5 hours into C++, upwards of 108 hours, depending on how you define a stream. So yeah, that seems about right for where we're at. Okay. So what's going on here? So Sassy Fajita, do you want to link me your solution to rotating rectangles? I'm not going to copy and paste, but I want to see, like, I'm sure you do a struct. I'm almost guaranteeing, but I'm more interested in the math part of it to make sure we understand our cosines and sines correctly, because holy cow. Sure thing. Yeah, you're right. I just real quick, I'm gonna do something goofy here. I'm gonna change these minuses to pluses and these other ones pluses to minuses just in case we don't get our directions confused. I want to see, if nothing else, I just want to see what happens. Not that I'm trying to reinvent trigonometry here, but oh yeah, that's actually significant. What's funny though is look at that bullet on the oh my god, I'm just trying to come on, I just want to see the thing. Okay, look at that bullet on the enemy. I know you guys can't see it that well, but that bullet has a collision box that's almost completely on track, whereas previously it was flipped behind, and that tells me something's wrong with no. Do you guys think it's a translation issue, not a rotation issue? Because if you look at this, okay, look at where these bullets are in terms of where they are. It seems like if it's not a rotation point issue and it's not a math issue, is it a translate function issue? Because we are translating these every frame to keep up with the actual rendered hitbox or the rendered sprite. Did we do our math wrong on the translate maybe? But the translate worked here on our big, I know you guys don't even see it. Hold on. Move. On our big square down here, that worked. You want to look at the function main, rotate in place? Oh, let's see. Okay, what you got? What you got, chief? Okay, I wrote this in Mac OS, so no access to modules. Oh, you even wrote comments for me? I feel so spoiled. Array, complex, IO stream. Imagine having to hashtag include in 2024. I don't have SDL. See wiki, SDL, SDLF point. Okay. Oh, so you made an SDLF point based. Float X, float Y. By the way, a float SDLF point, that's not just a struct for 2 float values. That's actually 2 float values that C libraries. It's in the language of C, not C++. I'm gonna be honest, chat, I don't know if float actually exists in C. I use the sequel, not the prequel. Pi can be represented to 7 decimal places as a float. Oh, we did that. Hold on, look, MPi. Oh, no, it's a little longer. I thought they only went to 7 digits, but it looks like SDL actually defines pi going out to like 40 digits, 30 digits. It's hard to say, but that's how far it goes for pi. Float pi. Excuse me. Code toil. Float exists in C. Degrees from radians. Return radians. So you call a function for any kind of radian stuff, sorry. Radians from degrees. So that's how you translate between the two. Oh! No, this is correct, because we're going from degrees to radians, which you divide by 180 to do. Yes, you want radians out of degrees. Okay, sweet. So we have our struct rectangle. Rectangle defined by 4 points. Yeah, we do the same thing. Top left with height. Interesting, you define... You have a standard array with SDLF point struct and 4 values. And you give it a top left, a width, and a height. I wonder why. I wonder what the 4th value represents. Oh, you got the what's up approval. Okay. All corners of the rectangle should be ordered clockwise for rendering. For vertices. Okay. Rotate the rectangle. Angle degrees clockwise around. Reference point. Okay. Void rotate const SDLF point at address of reference point. Float degrees. Rotate the angle around its own center. Rotate in place. Float degrees. Move this rectangle so that its center is on point. Center at... That I didn't do. That's different. I thought if you rotated around a point, we were already accounting for the X and Y values. which is what this whole line is for, where we're taking the distance of the rectangle, the old rectangle point we were going from, subtract it from the rotation point on the screen. Same thing with the Y value, and then you add on the point at the end. And I thought the adding on part with the X and Y value would make it so that when you rotate it, it wouldn't be like way off kilter. It would actually be around the rotation point. Is that not what we did? And then get center returns the center point. No discard. Friend STD O stream. Rectangle, vertices 0, vertices 1, vertices 2. Oh, I get it now. Oh, that's why you only had 3 values. You weren't defining the parameters of the rectangle. You were defining the parameters of the vertex. And every vertex needs 3 values, the X, Y, and height? You guys get it, right? It's the X, Y, and offset maybe? But I see what you're doing now. Get center. The center point is just the average of all the vertices. Rotate. Okay, what are you doing for rotate? Const float radians, defined as radians from degrees. Rotate each vertex of the rectangle about a reference point. For reference point at vertex, vertices. So what you're saying is that for every vertices, do this. Translate the points to complex numbers, multiplication in the complex, rotation, STD complex, ref CX, reference X, reference Y. Now that is a term I've never heard. What is this? What is standard complex? Specializations of STD complex for CV unqualified standard. C++ 23. Oh, we gotta use this feature. What do you got here? I don't see it. Specializations of conflicts for CV unqualified standard until C++ 23 floating time. Oh wait, no, I can't. This is old. Because I don't get access to complex float, double, or long double. Instead, everything is just complex. Oh, sweet. I guess that's better, huh? I wish I knew what it actually did. Computes the sign of a complex number. Implementation notes. In order to satisfy the requirements of array-oriented access, an implementation is constrained to store the real and imaginary parts of complex. Well, what is a complex? Oops. STD complex. No! A complex class is designed to hold 2 elements of the same type representing a complex number in its Cartesian form. Oh, which is, oh, wow. Okay. So Cartesian is X, Y, Z, like, graph, right? It's an XY graph. So what we're saying is that if 2 elements have the same type, like a float or a double or an integer or object type that you define probably, representing a complex number in its Cartesian form. Okay, a complex number can be represented by the sum of a real number and an imaginary part, y times I. So x plus y times I. The imaginary part is a factor of I, known as an imaginary unit. Okay, I squared equals -1. So the square root of I. Or sorry, the square root of negative I. I think that's imaginary number, right? In this class, complex numbers have 2 components, a real and an imaginary. The class represents a certain functionality aspects of the regular numeral types, allowing them to be assigned, compared, inserted, extracted, as well as supported some arithmetical operators. It is a literal type, internally organized as an array of 2 elements of type T. The first is the real part, the second is an imaginary part. Okay, I got you. That makes sense. Yeah, so we have a constructor, which is the complex number constructor, an imaginary part, a real part, and then operators. Okay, that's cool. I haven't seen that before. So you have a complex called reference CX, so the reference complex, right? With reference X and reference Y, where reference X is the real number and reference Y is the quote unquote imaginary number. I is equal to the square root of -1. Oh, that's right. Thank you. Sorry, it's been a long time since like 9th grade. Listen, 9th grade was half a lifetime ago, okay, chat? Oh my God, has it been longer than half time? Wait. When am I gonna die? Hold on, let me do math in my head. Let me think. I would have been in middle school in 2005 and 2006. Oh my God, that was more than a lifetime ago. Oh God, I kissed my first girlfriend in 6th grade, chat. Jeez, time flies. Standard complex vertex complex with the definitions of vertex X and imaginary vertex Y. I do that imaginary in quotes in my head, by the way. Update vertex complex with the new rotated vertex. Okay. Vertex complex is equal to this vertex. Oh, no, sorry. Vertex complex is equal to the value of vertex complex minus the old referenced. Okay. Where are we getting vertex from? It's this, right? So you're saying that you have an SDL floating point value of an X and Y. Belial is Belial? Balala? Thank you for following. How do you say your name? Is it Belial or Belial? Belial is disgusting, but Belial sounds like Bale from Diablo 2, and it makes me hate you a lot. So I don't know. Which one would you prefer? Or is it Belele? That'd be cute. So you have a couple of variables here. You have a vertex. Then you use that vertex X and Y value to make a complex number. You also referenced your X and Y, which is your floating point reference number. Okay. So where are you getting this from? Where are you getting SDL floating point vertex? I see vertex stuff here, but where did you actually make this? Oh, Control F, SDL floating point. So I see SDL flow point here. Ah, there it is. Okay. So you make the vertices of a rectangle here. Okay, gotcha. So now you make your new struct defined with these vertices, and that's how you get your vertex or your vertices SDLF points. Okay, so you're saying for every instance of vertex, do this thing. Gotcha. Like you said, vertex complex is just vertex as a complex number. That's an enhanced for the loop, so I'm looping through each vertex. Yeah, I got you. Sorry, you're using C++ language I haven't even seen yet. Sweet. So what do we got here? Vertex is the average of X, average of Y. Yeah, that's how you get your center, yeah. Okay, so complex. So you have your new vertex complex is equal to vertex minus reference times polar? Ooh, that's a cool one. So many lingu I haven't seen before. So STD polar returns a complex number with magnitude R and phase angle theta. The behavior of is undefined if R is negative or not available, or if theta is infinite. So theta always implies an angle, correct? Theta is an unknown angle or a variable angle. R, I'm used to seeing as radius. Oh, it's defined right there. Magnitude. Okay, sweet. I don't know what magnitude means in this context, though. Like, phase angle makes sense. Is magnitude like... I don't know what that means in this context, actually. Complex number determined by magnitude and phase angle. So no, polar is equivalent to any of the following expressions. STD standard at EXP, theta times lie times magnitude. Magnitude times the cosine of theta plus the sine of theta times lie. STD complex with the value of r times cosine theta as your x value, and r times sine theta for the y value. So this is equivalent to polar. Gotcha. Using polar instead of EXP can be in about 4.5 times faster. Holy shit. Wow. Yeah, rip EXP, whatever that is. I can describe how this works if you need, by the way. It can look weird. I think I'm getting it so far. Just remember that my math is like trigonometry, like first week. Like that's the limit of my math skill. So excuse me if I don't recognize something immediately. So this is super similar to what you're doing. So polar is efficient, defined by the x value, the magnitude, the y value, the theta. Okay. So your x value is the floating point number, which is 1.0. Your y value, your theta is your radians, which you've already defined as here. Radians is radians from degrees. So you turned like 45 degrees, you turn that into radians, and now that is your y value on your polar, which is your theta. And then you add that to the reference number. Revert from complex number to SDLF point. So now you have vertex, which is the previous value you had before, is equal to the value of vertex real and vertex imaginary. So that's not really, but it's a glorified x and y value. So vertex complex dot x and vertex complex dot y. It's not really what it is, but it's a complex number. Okay, so that's your rotation function? Okay. Interesting that nothing in here accounts for the center point, interestingly, but okay. Rotate in place. Okay, there, that's what I expect. Okay. Oh, no, I lied. Oh, no, that isn't. I didn't lie. This is rotate, and this is rotate in place, calling rotate, get center degrees. Oh, and that's your SDLF point. Oh, that's your SDLF point. So that's why you add and subtract compared to the reference stuff, because the reference is your center point. Oh, I get it now. Then you have center at. Okay. So what do you do for your center at? Vector pointing from the center point. SDLF point difference is equal to get center, which you've already made, which is the average of all the vertices. Difference, that difference value, dot x is equal to point x minus different x. So this is the center of the rectangle you just made, I think. Move each vertex by the same amount as the center. Yeah, that's what it looks like. No, I lied. You're not rotating your rectangle. You're taking your rectangle and you're centering it. I think that's all you're doing there. Then you have your O-stream operator. O-stream const rectangles. This is just printing the values. Okay. So I think our problem is, chat, just looking at that, I think our issue is when we have our rectangles on screen, the problem here is we're never taking into account of centering the rectangle. I actually think it's rotating correctly. Everything we've tried so far seems to, the big square down here kind of successfully shows that. Rotations work. The problem is at no point are we ever centering the rectangle outside of actually just rotating the freaking thing. So if that's the case, how do we... I think that means we should center the rectangle first around the rotation point and then rotate it. But is that not already accounted for when we rotate it? Because we have minus rotation point being where we're rotating around. We already account for that when we have our, you know, first X value. And then we subtract the Y rotation point, and then we add X back on. Because all we care about is the X value here. Is that the issue? Or do we want to add... No, we do only care about .x, right? Which is what this point is. 0 and 1 are the X and Y value of the top left of the rectangle. 2 and 3 is the top right. 4 and 5 is the bottom left. 6 and 7 is the bottom right. You sure you're rotating around the center of the rectangle? Yes. Because the center of the rectangle, on creation of the game of any bullet, is the X and Y value plus, it's the middle of it, the middle of the bullet, right? Which is what our intention is that it be in the middle of the bullet. Then it gets updated before we rotate anything. The rotation point gets updated here. The X and Y value is equal to the middle of the rendered sprite on the screen, the rendered rectangle we have, right? The X and Y value is equal to that. So it's in the middle. Then we call rotate collision rectangle, taking the collision value, which is the box we want to change. We take the rotation point, and then we take angle. Yeah, we can't even call SDL rect here, so we do have the correct one. Then we rotate, and then we have our angle that we're rotating with. Angle is defined in that instance of object, which is all taken care of here. So this set collision angle gets made on object creation when we actually launch the attack, right? We create all 10, 20, 500 bullets, or well, 255 if it's a one attack. 255 bullets all goes into a giant vector, pushed back 255 times, and then we empty out the vector every rendered frame, and every bullet launches where it should. AKA, the rotation point is the center point. Yeah, that's the goal. Wait. Do you guys think the problem is the rotation point is actually based on the original sprite image that's vertical, and then we rotate around that, and then we rotate the bullet again to render the image? Well, that would work. I'm gonna go back to lurking. All right, see you in a bit. I think that's right. So if that's the case, our rotation point this is correct. I'm almost entirely sure, because in order to change set velocity and set position changes the render box. Set velocity is the X and Y velocity. Set position sets the X and Y of the position. Actually, wait, move calls set position. Why? Oh, because we need to call move every frame. And this gets updated every frame. Do we want this updated every frame? How about instead of that, we do this, where bullet position Y is actually position X and position Y. What if we do that? Okay, so we need to translate every frame. But what's interesting is that absolutely nothing worked here. But it is interesting. Hold on, did that not work? Hold on, hold the phone. Let's change this to 2 real quick, and let's change bullets launched to 2 instead of 3. I want to see what happens here. Okay. Interesting. So now we're going to translate every frame. In order to translate, I have to call this. Oh, no, we did want that every frame. That is what we wanted. Because we wanted to translate every frame. This doesn't call set position. Oh, yes, it does. Wait. No, that is correct. Okay, hold on. So now we're going to call this function that calls all of these. That's the only difference here. Okay, interesting. So it seems like we have issues. What is the issue here? The bullet on the right. Well, the bullet on the left is just 90 degrees off, and that's all the issue with it. Is this like an undefined thing? Is this like because the bullet on the right and the bullet on the left are on perfect horizontal degrees, 0, 180? Is there like an issue with our sine and cosine functions or something? I wonder if that's the issue. Do you think? That would kind of make sense. What happens? Hold on, I want to see what happens if we shoot 4. Unit test? Well, the thing is, this whole stream so far has been like going from the beginning where everything is and goes. And it seems like the issue here is just... Yeah, look at that. Isn't that weird? Going from 2 bullets to 4 bullets makes the bullet on the left totally cattywampus. In fact, it seems like everything is like 90 degrees off. Okay. So if that's the case... I'm trying to think about how to fix this. If cosine angle is equal... Cosine equals, is invalid at, what, 90 and 270, right? Seems like you're getting close, though. Yeah, we are getting closer. If equals 90 or... cosine angle, I am going off no knowledge of trigonometry, 270, then cosine angle is equal to 0? I don't know if that's actually what we're looking for, but I think I want something like this, because I think the issue here is our undefines are weird. Except this is going to be 180 or 360. Let's see what happens there. No, that didn't work. Yeah. So what are our hitbox spawning at? Hold on. Where are our hitboxes spawning? The first 4 bullets spawn at 124, 118, 100, 94. They all have a Y value of 55, of 109. This is correct. These 2 values are correct. And that value is the length of the new rectangle, I think. Right? I don't remember what that prints, but These might be weird. I don't know. It's hard to say. It prints the top left corner, top left point. Oh, the rotation point. Oh, we already do print the rotation point based. Well, hold on. Let's shoot one bullet then. Okay, so the rotation point of bullet 1 is... Can you not, please? Thank you. So the rotation point is going to the right. So the Y value stays the same. That's correct, because it's going to the right. Yeah, this is the rotation point, which is, you have this little dash here. Thank you for following, GMA Warrior. Oh, your name reminds me of Dynasty Warriors. What a great series. This value on the left is the X and Y coordinate of the top left of the rectangle collision box. And this is the center point, the rotation point of the box it's rotating around. Draw a plus on the rotation points. I mean, we can see it here just mathematically, right? So in this case, 110, 155. So it's going to the right. Oh, wait. It's not going evenly. What? 62. 55. 61. 62. 56. Wait, why is there a variable speed on the rotation point? That's weird. Well, how much is our X value changing here? So we have 125, 187. That means that it's going horizontally at 52 units. No, 62 units. Okay, that's correct. That matches with our rotation point. Then it goes up 55. That matches. Then it goes up 61. That matches. Then it goes up 62. Matches. Then it goes up 40, 50, 66. Yeah, wow, it's the same. So they do match their X and Y values perfectly every frame. Or at least this is, well, no, that is not true. That is not what we're looking at. This is just the X and Y value of every individual shot we shoot, but not the same point. Okay, maybe we can print that instead. Okay. Well, let's copy and paste that. Let's look, let's do a little debugging. So copy that, go back to game logic. I don't want to print every bullet though. I wish there was a way to only do this once. Timer equals 0. Guess we can just have this at the end. Okay, so now we have our bullet instance. So list containers, bullet, no. Oh, we should have it in our for loop, huh? Yeah, because that's where we have our list containers. So this is gonna be L bullet dot. Fuck. How do I grab that number? Oh, we don't know that number, do we? Shoot. We don't know the collision rectangle because that's technically a separate entity from the bullet object, isn't it? What font is that? It's so ugly. Oh, it's ink-free, bold, size 10. Overlord Vim. Your name sounds familiar. Probably because of Vim. How do I grab that angle? Is it the M collision box, I guess? So M collision underscore bracket 0. Yeah, I got it. So L bullet M collision, whoops, M underscore collision, bracket 1. Then we have rotation point dot X, rotation point, no, L bullet dot rotation point dot X, L bullet dot rotation point dot Y. Okay, so now we're gonna see it print one bullet. Go. Okay, so what's going on here? This is one bullet moving to the right. So we have, oh shit. We're not moving the rotation point. That 171 is the second bullet. Does the rotation point need to move? I don't think it does it? How is your progress? Oh, I guess it does need to move, because what if we want a rotating bullet in the air, huh? Andrew, hello. We're just printing out some debug stuff. So we have a bullet shooting on the screen. The left value is the X and Y value of the collision box, and the right is the X and Y value of the rotation point that collision box rotates around. So when it starts at, rotation point is at 110.55. Now, our top left of our collision rectangle is 103.40. Now, it stays, the Y value stays the same because it's on the perfect X-axis. It's just going left. So if that's the case, it should not move relative to object, but it should move relative to the screen. What? Isn't it a 2D game? Why do you need the bullet to rotate? Well, what if we shoot like a ninja shuriken and we throw it in the air, or like a boomerang or something? Like a boomerang. You throw a boomerang, it needs to rotate around a point, and the point is where the object is going, right? And the collision box matches the boomerang, like that kind of deal, right? So that's an example. But it goes to the right too, so this is correct. The collision box is matching, but clearly something is wrong here. Because the bullet, hold on, when does the bullet actually launch? Real quick, let's make it, how do we like launch one and then wait? I guess I could launch one outside of the main loop. I guess that would be fine, right? So we launch one here. Go. Okay, so what happens? We launch one immediately. 52.44, 59.59. Okay. That's bad. Because the bullet doesn't launch at 52.44. It launches at instance start, and the enemy itself is at, well, I mean, shit, we can make it 0-0 to make it easy. Because it shoots from the bully, or bullet. So instead of 40-40, let's do 0-0. Okay, what's going on here? Might have waited too long, hold on. Okay, so it launches at 12:14 because it shoots from the middle of the thing. Well, that launches. The collision box is 12:14, and the rotation point is 1919, which I guess on a 40 by 40 pixel enemy, 1919 is fine. It's close enough to the middle. I don't care. So that's correct. The rotation point is correctly in the middle of the image. This is my question. Is that really the top left of the rectangle? God, I'm trying to catch it immediately and I just can't. What if we make the attack? What if we make this like, well, I guess I should make this 1, huh? 11.4. You know what this tells me? That box, look where it is relative to the enemy. That's to the left of the enemy. That should be a negative value on the top left of the rectangle. Correct? Wait, hold on. Is the box? No. If we're rotating around the center, the bullet starts straight up, so it rotates to where it needs to be. Now, in this case, it's going to set to 0 degrees, which is on the right. So I guess it technically rotates to the right, which tells me it might be a translation issue because it rotated correctly, but it's not on like the same... Hold on, let's check our translate function. Did we fuck up something there? Okay, we have translate. Let's see here. Correct delta x. So new x subtracted by the old value. New y subtracted by the old value is equal to the change in y, change in x. Then the x values are going to be added to the old delta, or the new delta, I guess. The y values are going to be added by the delta. Should this be the old rectangle minus the new value? Well, not necessarily. If it's the new value minus the old value, so if we're going from, you know, x is 50, we want to move it to x is 100, would you go 100 minus 50 or 50 minus 100? Well, it'd be 100 minus 50, right? Because you want to progress forward. And vice versa. If you want to go from 50 to 0, you want to be 0 minus 50, so you move to the left. So that is correct. Then, in order to move, you have to add that new value to the old value, which is correct. You want to move 50 to the right. You want to subtract 50 to go to the left. Okay, that's all correct. Our translate function does work. We're not even calling resize yet. That's its own nightmare. We haven't even called the boundary rectangle yet. 0, 1 is the top left. 3, 4. No, it's 2, 3. 2 is the top right. Well, 2 is the right and the top of it. 5 is the bottom. 6 implies the right. Wait, what? Create collision rectangle. Wait a second. What did I do? Hold on. 0, 1 is the top left. 2, 3 implies this is the x value is the right side. The y value means 0, so it's the top right. 4 is the left. 5 is the bottom left. Okay, so we go top left, top right, bottom left. 6 and 7 apply the bottom right. Okay, so that is what we expect. We kind of did a Z shape there. We did do a Z shape. Is it like a print issue? Print points. Render rectangle, points data, points size. Where are we getting points size from? What is this? Oh, you're printing the size of the vector or the array. Gotcha. Yeah, at this point, I just take what's up as advice and start drawing things to quickly locate the failure point. But I mean, don't we already draw everything? This is all the drawing we really need, right? Something is going on with the I still don't know if it's the translation or the rotation. It seems like the translation's working perfectly because you have to translate it every frame, right? Yeah. Set position. We call set position every move function, which is called every frame. So that does get updated correctly. It is correctly translating it. Hmm. And we're rotating. Why? Why is that not working correctly? We set the angle first, so the angle of that instance of bullet does indeed change. So this still applies correctly. The angle does work. M collision changes. Rotation point. This collision rectangle does return a rectangle. That is true. Although I guess I do have a question. What's the point of this? Oh, I guess because we're changing the values of it? Okay, that's fine. Without messing with this. Because we do want to return the original array we put in, I'm assuming. Maybe it is like a center around the position? Move it, render the collision box. That's not gonna make a difference, right? If we render the collision box or not, 'cause it's all rendered on the same frame. Yeah, okay, that doesn't matter. I don't know. I actually might be listening to what you guys want to do now, because I'm a little lost on this. I don't know what else to do. I am waiting for Gary to tire himself out. By rotating, you mean the bullet should arc, right? No. We're not applying like physics or anything. I just want to rotate the collision rectangle so it matches the sprite. Because we can resize it and stuff later. But at this point, we have issues. We have issues with it. Like let me shoot 3 bullets here, and you'll see what I'm talking about. We have issues with the rotations being like all over the place. Oh, I'm sorry. Hold on. I gotta... whatever. We shoot out 3 bullets, and it's like the collision box is like all kinds of messed up on it. But there seems to be no pattern to it. No, he's just rotating the red rectangle that's drawn to be around the bullet. Yeah, basically. So, where are we going from here? So you guys know about debugging better than I do. What should we do? You done yet? Okay, yeah, I'm done. All right, rub it in. I get it. But like, where do we go from here? Because I don't know what else to test. Like, you guys say test unit by unit, but what exactly are we testing? Mentioned drawing something on rotation point to make sure that is dead in the center of the bullet. Draw the bullet pellet in bullet list. Okay. Hold on. SDL, render, draw, point. Which takes integers. Fuck! I know it's F point. There we go. No, I do want it called here, don't I? SDL, draw, or render, draw, point F, where it takes the parameter of a float or a renderer, which is app dot global renderer. Oh, sorry, app arrow global renderer. Then it is L bullet dot rotation point dot X, L bullet dot rotation point dot Y, semicolon. So now that's gonna draw that. So now in the center of the bullet. Oh, it didn't move. Oh, because I only drew it once. You guys don't even see it, but it's a little plus right there. Right there. Which I guess is kind of hard to see, huh? Maybe make a red rectangle with a gradient. Maybe we can see much better. What are you doing? Drawing the pellet? Draw the pellet in bullet list. Okay. We do render the bullet here, though. I mean, should we just not move it? And then, hold on. Let me spawn it at 100 by 100. Oh, that's the enemy, you moron. Good job. Oof. Huh. That is very difficult to do, guys. I mean, we do render the individual instance of bullet, but it's only when we spawn the bullet. Draw the bullet list, bullet pellet render. Okay. I guess that would be smart, huh? So render there. Because we are missing a semicolon. Go. Bullet list should not be capitalized. And it should have a... no, that is correct. Oh, it's list containers. Okay. Okay. Okay, go. Oh, fuck. Oh, my God. Bullet render does not take 0 arguments because you need app, arrows, global renderer. Go. Okay, so now we have a bullet. Problem. Collision boxes are not attached to the object bullet. That's the issue here. Draw the collision box. Okay. Okay, so... I don't know if you can. The problem is that we create the collision box here. The collision box gets created. Wait. Here. That's where it gets created. Do I have this implementing collision rectangle yet? I do. So I guess it does exist then, huh? I guess I could just do it again. List containers dot bullet list dot this. Oh, it does exist then. Oh, you're right. Okay. So create collision box already exists. So now M collision. How do I print that? With this? Render my rect is what it's called. No. Oh. No, unless I made it, that won't work. What was that function I wrote for you to rotate rotated rectangle? Oh, to render it. Oh shit. Okay, you're right. Render my rect. And then we have app, global renderer, comma, that, parentheses, semicolon, go. Okay, and it's perfectly on. Yeah, see? You know what, chat? Hold on, let me make it a little easier for you. Let's just make that bullet bigger. Would that make things easier? Hold on, we'll do 50, comma, 50, 180 by 300. This might make things easier for you. Boom! Oh, look at that beautiful collision box. Oh man, that is juicy. Why not use the debugger? Because I have literally never used the C++ debugger in my life. Brownie man. Okay, now write a function, render a point. Render my point. Oh, okay. So I don't need that. I mean, I guess I could just make one. That looked like a woman's private part? What? No, that looks like a bullet. Chat, don't be pervy. Okay, so now, bro, you aren't using Visual Studio to write code? Aren't you using it? No, I'm writing this shit myself. So SDL, render. I guess I could just copy and paste this, or just move it, I guess. So copy, paste. I know you guys are gonna have a hard time seeing this, but bear with me a second. Copy, paste, paste. Okay, let's try that. Okay, you guys don't see this at all, but right there where this little square is, it rendered right there. I'm highlighting it. I can see it on my screen. You guys probably can't, but it's a little point right there. And that is indeed the center of the screen. I would render a plus to indicate a point. An X would be simpler, but an X is simpler. Oh, I mean, aren't you using Visual Studio as an IDE? Buddy, I'm only 100 hours into C++. I'm barely using like my brain as like a programming anything, all right? So you need 2 lines, 4 points that crosses a specified point. I get it, what's up, for your guys' sake, but for my sake, we're debugging right now. This point suffices. I can see it just fine. If I ever lose it, we can do that exact thing. But as it is, this is fine. Now that being said, now that we know the collision box does render correctly around the rectangle bullet, and the rotation point is in the perfect center of it, now I'm guessing we test the rotation, right? We just rotate it 90 degrees. In which case, we call, what are we calling here? Did we just call set collision angle and then just rotate it 90 degrees? I guess I can just give it a parameter, huh? Rotate it pi divided by 7 radians. No, the angle already translates from degrees to radians. So what we're gonna do is just give it a new SDL F point. No. Float new angle. And just give this new angle as a parameter. And that should be all we have to do. So now we have... So now we have float new angle equals 90. Well, that's not good because it's already vertical. No, that is fine. If it starts out vertical, 90 degrees just makes it horizontal. And then list containers dot bullet list bracket bullet ID blocks pellet end bracket dot set angle? Is that what I was doing? Set collision angle. Now technically this will only rotate the collision box, but that's fine, right? And then we have new angle. Boom. Save. Build. Failed because that's not it. Does not take 0 arguments. Oh, this needs a new value. Oh God. Delete this for now. Okay. Okay. It is now spasming because every frame we're rotating it 90 degrees. Oh. Okay. So I'm doing something goofy here. So before we do anything, let's do this. Let's save it. Come back here. Delete that. Okay, leave that as is. Come back here. Delete that. So now, what do we test? Because clearly that wasn't the correct answer. So this is correct. So now that we know where the rotation point is, what am I testing next besides rotation? Why are you making it harder for people to want to help you, man? Oh, I'm sorry. No one in chat can seize the point you render. I can see it. And in the end, isn't that what matters? All the collision stuff happens on bullet move, right? No, that only translates the rectangle every new frame based on where the bullet's moving. As far as the rotation is concerned, it doesn't touch it. It just translates the rectangle. Right? Render my point. That's not what matters. Oh God, fine. I'll make the point easier for you to find. We'll write out the function. Void render my point. This will take a parameter of an SDL renderer pointer. Renderer takes a const SDL f point. Yes, that is a floating point there. We'll call this rotation point. Then we std array SDL f point 1 2 3 4. Wait, what am I doing here? We have to draw, it's almost the same thing as this, except we're drawing this plus minus like 20 or something like that. That's not what matters. You are not matters. The program is. Drop the ego, moron. Is that what it is? Watch render my point just be a pass through to draw a single point. No, it's easy. Watch. So we have a rotation point. So the X value. How do I do this without making a bunch of variables? Is it going to be? It's going to be SDL f point. Oh, we're not taking a rectangle in though, are we? I guess that doesn't matter. It's parentheses rotation point dot x minus 10 comma parentheses rotation point dot x plus 10 end curly braces comma curly braces, and then we do the same thing. We just do copy and paste a few times actually. Paste, paste, paste. Last line's a semicolon. Except this is dot x. Wait. No, that's stupid. No, this doesn't work. Oh God. Wait, that's x and y value. So this is rotation point dot y at all, and then we're not moving it. Okay, so this is x plus 10. This is still y because we didn't move it. This is y minus 10 x because we're not moving it, and this is y plus 10 dot x. Okay, sweet. So now, why does the semicolon have an issue here? Oh, because it goes after. Okay, now SDL render draw lines. It's almost the exact same formula. It is the exact same formula. Okay, now nobody can make fun of me anymore. So instead of SDL render draw point, we have render my point I know we have to prototype it. Chill the fuck out. Comma, list containers. Okay, this. But it's actually dot rotation point dot x. Oh no, it's just, there you go. It's just that. Semicolon. Oh, and then I have to prototype it, right? Okay, well, that wasn't really what I wanted, but okay. We drew something. We call this twice. Render draw line. No, I did it. See? I drew the thing. I just did this correctly, and then the Y values went all fucky. What did I render here? So we got the x, negative x plus x, and then whoop, up here, and then that. So the fuck did I do? X minus 10, no value y. X plus 10, no value y. Y minus 10, value x. Y plus 10, value x. So what's the issue here? Is it because I'm drawing a line between all of them? Agile is overrated. I always see people hate Agile. It was what I do Agile because it's kind of based. Okay, so the issue is that we're drawing multiple things here incorrectly, huh? So it is two separate lines. So we do need two separate float lines to render to. But how do we don't want size. We want, we have to put like size 2 elements or something. I don't know how to, this is why I don't like copying and pasting functions, because I feel like I'm kind of queasy on like actually changing anything. Don't give my company ideas. They'll make me Twitch stream my development all day. Hey, I learned a lot. We're uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools. Oh, so you like other people correcting me instead of me doing what I should do, which is correcting myself. Oh, that is the Agile Manifesto. Oh, okay. I mean, it sounds kind of based, to be honest. I don't know anything about Agile, but yo, maybe I should look into it. Agile, as it is in its manifesto, is great. Corporate people mutated into something horrible. Ew. So points data and points size. So this is talking about the array. I'm assuming data is this, and the size is how many instances, which is an integer. I'm not sure why I would want integers in draw lines, but okay. What does that mean? The renderer, the points along the lines, the number of points, drawing count, minus 1 line. Oh. The number of points, points along the lines. So does that mean this data is counting this is how many points are on the line? So this should be 2. And this should be 2. Whereas this... How do I say, is it 2? Basically, I'm trying to make it so that this... Is it points, bracket 0, comma 1? No. Trying to make it so it only draws like 2 elements of each. If this is like a syntax thing, you might as well just tell me. Render draw lines draws connected lines, not disconnected lines. Well, that's why we have 2 of them, right? Maybe you should just use render draw line F as a singular, not plural. Well, no, because then you just get like a cross. Well, then you get like a giant connected line, and all I want to do is make a cross. By the way, this is only so you guys can see it. I can see the point just fine. Yeah, I know. I already had this. Oh, wait, what? Draw line F. Oh, I drew point. Okay, I'm a moron. I'm sorry. Yeah, we have render draw line, not render draw point. Thank you. Okay, so we have the X, Y, X, Y. Renderer. Oh, okay. So this is the X value. This is the Y value. And each one contains an X and Y value. But why does this say, when I look up this, it pulls up a different function? Am I crazy? SDL render draw lines F. SDL render draw line. Oh, line. Oh, shit. I'm sorry. I didn't realize those were separate functions. Okay. My B. Okay. That's my B. Okay. I get it now. All right. I understand. So this is. Okay. So now we need different float numbers all over the place. So this will take. I mean, can I just copy and paste this in here? Instead of the parentheses? I guess we do want the parentheses, don't we? Okay, and then parentheses here. Ugh. Okay, wow, that was easy. Well, why'd you guys have to make this so complicated? Jeez. Could have drawn this shit without a render my point thing all day. Okay. Delete all this because that's useless. Okay. Wow, that was really easy, chat. Why did I make that function so complicated? So now this'll work. Go. Fuck, how does that Y value go way up there? The shit? So we have our X value, but our Y value is all kind of cattywampus. So what's going on here? Y minus 10. Oh, because I have my X and Y values backwards. So this is X. This is, oh, that's why it didn't work before. Oh shit. Because I had my X and Y values backwards. My bad. Tee hee ooh woo. Don't you guys forgive me? Okay, there we go. Okay, problem solved. Now we have a cross. There we go. Okay, is that better, chat? Is everybody happy now? Everybody can see the rotation point. Everybody's, ooh, look how impressive Gary is. Ooh. All right, chat, what's the next step? I am the programming master today. We're getting this done today. I am done with collision rectangles, okay? No more collision rectangles after today. We're solving this right now. What's the next step? Because I got your guys' back and you have mine. Okay, now we have a crosshair. Yes, thank you. Whew. All right, done skis. Easy peasy, lemon squeezy. So does anyone else want to hold my hand? Are we just rotating it now? Okay, now write another function, rendered my point with angle. Okay. I can do that. So copy, render my point with angle, where we also consider a float angle. Now, if we want to apply an angle to it, we might have to copy and paste something here. Because, oh no, wait, no, that's easy. I can do that right here. It's angle plus, no, angle equals angle times m pi divided by 180. That is how we go from degrees to radians, right? Yes, it's m pi divided by 180. If we're going radians to degrees, it's 180 divided by m pi. Okay. This function call the render my point, then draw another line that indicates the angle. This function calls render my point and then draw another line to indicate. So you're saying this should go here as well. Oh geez. Rot point. Okay. So that calls that function. So now everything's the same, but now we need to apply angle to the rotation point. Why did I put angle here? In fact, these should switch. It should be this goes up here. Angle is actually... Oh, now we need to apply it to the rotation point. Oh, God. Lord, hello, Lord. Hi. 0908. Chat, is it? Oh, you subscribed. Oh, based. Oh, thank you. Oh, yeah. That's half my lunch tomorrow, baby. Woohoo. Hell yeah. Let's hit up. No, I'm going to hit up Papa Murphy's. You got a $5.99 sale, boys and girls. Tuesdays. Thank you. Aw. It's your first time, too. Wow. And you didn't even do a Prime sub. You just raw dogged a sub, dude. Holy shit. Thank you. Hi, everyone. Hello. We have a length, an angle, and a point. Do math. I suck at math. Oh, yeah. You're the idea guy. I'm the implementer, huh? Am I your first subscriber? No. But thank you. Wait, why? Does it look that way? Do I look desperate? Oh. No, thank you. Do you like VTubers? What other VTubers do you like to watch? So, no, this is... Yeah, we change angle into radians. And then rot point dot x is equal to sine. Oh, I guess that can just be this. It's sine for x, cosine for... fuck. It's cosine... One time, I'm just gonna copy and paste this. Is it one times though? I don't think I want that. I think it's just this, right? Oh, I guess I can just delete this. This is just angle. Okay. Why is there issues here? Expression must be a modifiable value. What, is it not? Oh, because it's const. Oh, do I need address of it? Or the pointer of it? Or no, it's just const. All right, can I just make it not const? Okay, cool. This'll stay const. I really like your energy when I subscribed, man, so I thought it would be subscribed first. Good publications? Publications? Do I look like the goddamn New York Times? What am I publicizing? Also, we need more music. Hold on. More copyright-free music from Riot Games, boys and girls. Well, thank you. I appreciate it. Verherm in the YouTube chat. I see you lurking there. Length should be longer than the cross. Make it 15 times cosine. Okay. 15 times? The fuck? Are you sure? That seems extremely long, but okay. And then we draw the points. We render this first, and then we draw another cross, and we're gonna make the angle 45 degrees. I think this is all I have to do. I think. I'm pretty sure. Yes, it must be. Oh, this seems to be here. It must be. It has to be. All right. So now we're going to have render. Who followed? And you followed afterward. Oh, now you're just spoiling me. But it is not point. It's cross. Function is definitely named wrong. Listen, I'm just doing what I'm told. Cross length is 20, so angle line should be 15 or 40. Wait, length is 20. Make it 30. Okay. 30. We'll make it 35. There we go. Okay. Now let's go, and instead of calling render my point, we'll say render my point with angle. Copy and paste this. So we prototype it, semicolon, and then this is now going to take 45 degrees. All right, if everything worked out, we have successfully rotated. We're gonna have two crosses. We're gonna have a shorter cross that's vertical and horizontal, another cross that's completely diagonal. What the fuck? Oh, chat, what did I do? Oh. You know what I think happened, chat? Here's the thing, okay? This did work. Sort of. It is successfully 45 degrees, okay? It is of the length we wanted it to be. The thing is that we didn't draw individual lines to be that far. We drew, like we moved the point that far. So was that like a rotation issue or was that like a MyLogic implementation issue? But it did indeed rotate to 45 degrees. Nah, that's 30 degrees? Oh, you're high. Hold on, I'll fix that. Not fix it, but I'll show you what I mean. We'll do 15 by 15. No, 5 by 5. Go. What? Wait. Oh, it's rendering. Oh, it's not rendering degrees at all. It's rendering at 0.55. Oh, this should be sine. That might help. Nope, still 5.5. What the fuck? Is it this? Huh? Wait, did I not do this right? You have to add, oh, based. Okay, now that chat, that is based. Although I should just do plus equals, but whatever, I get it. Thank you. Okay, now we're getting somewhere. So now we'll do, 20. But we're gonna have an issue, chat, where we're not successfully rotating it so much as relocating it. In fact, this should be rotated 45 degrees, but we went 45 degrees clockwise, which is kind of weird. Unless we're saying that 0 degrees is defined as like down here instead of right here, which it should be right here. Wait, did I goof something here? SDL F point new point, SDL new point dot x equals 15 degrees cosine, or 15 times whatever. Draw a line, isn't that hard? Oh, geez. Also, plus 10 is definitely wrong. It should be different sizes depending on the rotation angle. Well, right now, let's figure out how to rotate first. So I think What's Up has the right idea. I think what we have to do is make a new SDL F point, make it equal to our new point, and make it equal to 15 times whatever. So this is new point dot x, new point dot y, and then we feed this all, oh god, then we feed this all new point, right? I think that's what you're getting at here. So here's the problem. This is still not going to be what we want, right? Yeah, it's the same thing. So I guess the question is this 45 degrees? I mean, hold on, I can make the lines. Well, no, no, we're not changing the lines. All this does is just tell me, wait, what does this do? 40, 40. Yeah, it just moves it further away. Wait, what? 120, 120. It's down here. It's right here. Huh. Interesting. SDL render draw line rotation point dot xm per new point x new point y. I'm sorry, I just started to learn and I don't understand what the number 1617 in the upper left corner of the window means. Oh, yeah, sorry, that is a SDL feature. All this does is just printing the amount of milliseconds since the last frame. You are correct, it's an FPS counter. This is 16.66 milliseconds per frame is 60 FPS. So this is just representing 60. If I ever see this number dip higher than like 17, like 18, 19, that means that we're having some lag in between frames. We're skipping frames at that point. Well, I don't know if we're skipping frames at all. I don't even think my program is capable of skipping frames. I think it just lags like Mega Man X or something. Okay, so we got a couple of answers here. What's up? SDL render draw line rotation point. Oh, it's because I'm drawing lines incorrect. Oh, you could have just said that. So I need to think about that. So my X value is just rotation point dot X, comma, rotation point. No, it's not. Unless I wanted to draw 4 lines, I guess. It's, I mean, I guess I could draw 4 lines from the center, but that seems inefficient. It would be new point dot X. Let me think about that. I know chat gave me the answer, but I'm trying not to look. Let me just think about this. If we're drawing 4 lines, but we don't know where it's rotating to, how do we draw the lines? Well, we know where the X and Y value is of where we're going and where I'm coming from. But how do I go where I'm going to where I'm going? Because we're drawing through the center line. It would have to be new point dot X. Well, no, I guess there is no through point. We're not drawing a giant cross on it. We're just drawing a line from point A to point B. So it's new point dot X, new point dot Y, rotation point dot X, rotation point dot Y. That'll do the same thing. Cool. Now we have a separate line. Sweet. You have 2 points. You're going from point to new point. Yeah, I got it. I did it. Andrew says, draw point X sine angle. Oh, so do it all there. Okay, I get you. This is some pseudo code. Oh, gee, I can't get out. This is some pseudo. Oh, geez, come on. Man, this experience. Hold on, let's just, there, enjoy the bullet. You have 2 points. You're going from rotation point to new point. I did that. I don't think he wants you to draw a rotated cross. I think he wants you to draw a line from the center. Yeah, now I know that. Thank you. This is why I don't want to use crosses, chat. It's because it like confused me. I thought the cross was like an object we were rotating instead of just specifying a point on the screen. Okay, now I understand. That's why I didn't want to use crosses, but now that we're here, I get it now. Okay, now make the bullet move, call move. Okay. Did you try where it is from where it isn't? Ah! Man, what is that font? Oh, hi, Painzan. Painzin? Yeah, your mom had pains in her butt after I was done with her. This is ink-free, size 10, bold, and I think it's cute. So now we're gonna call the move, which is fine. Do we call move after we render it? No, obviously not. We want to call this object, and we want to dot move it. This will not do anything as is. Never mind. What? Hold on, bullets. Okay, move makes 2 floats. Render is equal to the new, or these floats are equal to the render box. Then you add the velocity X and velocity Y to them. Then you set the position. Velocity X and velocity Y are set at object creation start. No, it's set under the attack. That's awkward. I think I have to set position. No, move sets position. That is correct. So I think I just need to call set velocity and just set 2 speeds. I think that's all I have to do. Boom. So we're gonna dot set velocity, and we're gonna do it to 1, 1. It should be 1.0 because they're floats, but you know, it is what it is. Okay, go. Okay, so now the rotation point isn't moving, so that's awkward. But that's fine, right? That's actually okay, because the rotation point isn't meant to move. It's not meant to be, although we should make it move. It's trivial to get it to move, right? It's more so about... Well, this is correct. It is actually moving in the direction I want it to for the angle, right? Because I set the angle to 45 degrees. Oh, no, I didn't even do that. I'm sorry. We set this velocity to 1, 1, which is bottom right speed, which is 45 degrees. So that's not the same thing, but that's how that happened. Give line 64 new lines. We can't see what's on the left. Give this one new lines. What do you mean? Oh, I see. I'm sorry. Here, let me zoom out a bit. Does that help? How's that, chat? In fact, would it be easier if I did this, chat? Hold on, I might make it even easier for you. What if I did this? Boop, and then boop. Well, no, my head's in the way. That doesn't really help, but there you go. I don't know, that's kind of tiny though. I don't know how much I like that, but there you go. That's the whole line. Yeah. Set velocity outside of the game loop. I mean, in this case, it doesn't matter, but I get it. Good practice and whatnot. There you go. And that's your point. That's your little line. So I guess now we want to rotate the entire bullet, huh? In which case, we need to set the angle, which is pretty easy. I can set that after we set the velocity, because that's what it cares about. So now everything should be moving to the bottom right side of the screen. What? Okay, hold on. I'm doing too much at once. Let's back out of that. Oh, because I voided, not list containered shit. There we go. Okay, but the collision box doesn't rotate. Okay, sweet. You need to get the bullet angle, not hardcore 45 in my render point angle. I mean, okay, I guess I can do that. So instead of doing 45 here, all we have to do is list. You're not even going to see this whole thing. We're going to call for the list containers dot angle, basically. So this dot angle. That's the only difference. So now it's going to look the same, but now it's... Wait, what? Huh? Wait, why is my angle backwards? Why is it pointing this way? That's weird. Why would it do that? That should be pointing bottom right. The red thing looks like an emerald. It looks like a rupee, but I get it. It's actually a bullet. It's gonna be what the enemy's shooting at us. Now we see the problem. SDL angle is clockwise. Why? would SDL angle be clockwise? I don't believe you. There is no shot. Where is it? Where is it? Set angle. Hold on, where is it? This. Inverse tangent is clockwise? No shot. I don't believe you. Compute the tangent with 2 parameters. No, that doesn't matter. This is like C. Why would a C programmer... Yeah, the arc tangent. No, this is right. That's the only thing angular related in the whole program that affects angle. Are you saying this shouldn't be 0 minus y velocity? Oh, God. Oh, no, chat. Did chat fuck me? Was it minus negative was it not 0 minus y velocity the entire time? First, set velocity outside of game loop. Second, show us the bullet class. First, I did set velocity outside of the game loop. Ooh, look how it exists outside of the game loop. Ooh. And then second, what did you want? No, inverse tangent is not clockwise. SDL angle is. I don't use SDL angle. Atan 2 is not clockwise, but the plane is inversed in SDL. Chat, hold on. I'm gonna draw this out. I know What's Up wants me to do something, but give me 1 second here. Let me cook. So you're saying that in our world of SDL, this is how it draws its plane, where this is the X value and this is the Y value. And then that's what we're changing is like circle rotation stuff, right? But you're saying that in inverse tangent land, they correctly use cardinal systems like this, where this is the X value, this is the Y value. So if we want to rotate something, say 45 degrees this way to make it like this, it's actually making this. Is that what happened? Which is turning into this direction because we have in negative Y. Oh no, that's why we have negative Y. That's why we have this. Doesn't that already fix the problem though? I explained this to you like 3 times already. Yeah, but I'm 3 times as stubborn as your average programmer. Regular inverse tangent 2, which is... Oh, wait, you wanted to see the bullet class. Sorry, here you go. I don't know what else you want to see, but that's probably the important stuff. Regular inverse tangent 2 is for plane. What is going from left to right, bottom to top. Gary, stop using 45 degrees as your example. I don't have 45 degrees. Well, in my paint example, sure. So this is my bullet class. So this is my inverse tangent. So velocity X, because that does share a value with SDL. 0 minus negative Y, because SDL flips it on the top. Use 30 degrees. Sure. So we want to set angle, where angle is... Where do I even have 45 set? Oh, wait, hold on. Where is my angle set right now? Because usually I had it with the tack. And M angle is where everything gets made. But I don't have an M angle. So what is the default value of angle? 30? I can't do that. Oh, I can. That didn't do anything. So I don't have an angle value. So do I do something like... Oh no, I do have an angle value. It's this. This is my angle value. So velocity X minus velocity Y, which is 1, 1, which is... Here, set velocity. That's how I get my angle. That's how we're getting 1, 1, which should be bottom right of the screen. So you're saying we should have like 1, 0.5 or something. Yeah, so there's your 30-degree angle. And indeed, it does switch to 30 degrees, but it's in this direction. So there is always a 45-degree offset. So to play that again, it seems like there is a 45-degree offset between the rotation of this. By the way, the rectangle still isn't fucking rotating. And then there. Okay, so now you must match them somehow. Well, it seems like it's either angle here or it's, well, no, it's not angled. This is correct. Because if it's negative velocity and we have positive 30 degrees as our output, which is x1, y 0.5, then it flips it. This is correct. Where the bullet's heading is indeed the correct angle. So this is all fine. It's this that's the problem. It's the rotation. Which means, do I just have my rotation formula wrong? Is this incorrect? Oh, should I be like minus y instead of plus y? Is that the issue here? Nope, that is not the issue, and I regret doing it. 20 times sine this plus y. So just to be sure, we're not drawing it incorrectly, right? It seems correct. Actually, for my life sample size, you fit in right in with other programmers' stubbornness. Thank you, I think. Switch 20 to minus 20? Oh, is that it? Oh, wait, hold on. Is it the X one I'm switching? That would make it not correct. In fact, it seems like both of them are no, not both of them are negative. In fact, either way, it's like minus 20 and then an additional like 100. It's off. It's not a negative or positive issue because it's offset by like 45 degrees. Pass Rice, Pass Rice, thank you for following. Oh, we're so close to 1,000 followers. We're 30 followers away. Oh my goodness gracious. And you have to swap sine and cosine? Oh, really? Wait, I thought cosine applied to the x and the sine the sine applied to the y. Is that not it? Oh shit. And now it's negative. Okay. That's the answer. Okay. So now, oh shit. Does that mean we got this wrong? Is that the issue? Does that mean we had our velocities wrong the entire time? Because here, under this, which is correct, it's number times sine for the x value. And under here, it's number times cosine x. Is this backwards? Usually that would be the case, but stupid planes are backwards for each other. So is this like a... But this worked before, didn't it? Hey, sure thing. Thank you! Sine is for the y, cosine is for the x. The fuck? But this works. Did I do it backwards? Well, in any case, we're drawing the line incorrectly. But now we have an issue where the rectangle needs rotated. So where do we call that? That is set collision angle. So I guess we try that next, right? So we already have a velocity and everything. So this should just update the angle. The fuck? It looks like a goddamn rocket ship. Why is the box over here? Oh my god, it's the exact same issue. Wait, is this really like a backwards? Hold on. Collision rectangles. Cosine angle cosine times cosine. So should this be negative? Okay, I don't know what I just fucked with, but I just made a parallelogram, and I'm kind of proud of that. Well, now I know how to make knife cutters. Oops, that was a redo. Hold on, redo. Why did you do that? Oh. Listen, math people gotta math, all right? So, what's wrong here? I think something is wrong. Oh, wait, hold on, delete that. I was fucking around there, sorry. So what's going on here? I need to rotate the collision angle by 180 degrees. But that means that we're missing like a negative somewhere, but I don't know where. Is it like a minus the rotation point? No, we should add, right? This is why when everybody was trying to help with the math, it kept not working. If you're trying to negate it, it would probably put parameters around the whole thing. Ooh. That Xander guy is following. Ooh. That Xander guy. I know a Xander. He snorted makeup in class once. Listen, when I went to school, it was a very small school, okay? That Xander kid was wild. A lady had her makeup out, and he's like, I bet I could do a line of that. And the kid just straight up did a line of makeup. I didn't even know that was, I thought he was gonna die. Angle is starting from the right. SDL plane rotated the positive angle should go clockwise if you do it correctly. Angle is starting from the right, and SDL plane rotated to positive angle should go clockwise. I don't understand what you're saying. So this is the problem is the rotation function. This is the issue. We have nowhere else to go. Multiplying both the x and the y by -1 should flip it 180 degrees. So you're saying put a parameter around every single function and then make it negative. Is that what you're saying? There must be an easier way to do this. There has to be. Oh my God, how do programmers do this all day? I couldn't. Oh my God. So just that, what happens? Okay, success. I don't know why we're making everything negative, but hey, it works. I'll take it. Not, Chad, don't even act like sometimes you don't have solutions where it's like, I don't understand what happened, but I'll take it. So we take the inverse of everything. That's weird. Oh, what? I don't get it. I don't understand it. How are we not even on the thing anymore? Oh, because you know why? I made y negative. This should go here. Sorry. This should go here. And then y should not be subtracted. My bad. We should add a flat value of y. The fuck? I'm just saying that if you think it's off by 180, that's how to fix that. I don't think so. We don't do this all day. We got emails to reply to. Hi, Jim Travert. What? I don't. Okay, so fuck all that for a second. So if we just change the x values negative, it does that. It shoots off. This does seem correct, where it's shooting off at the top right by 180 degrees. So then multiply it by -1. I mean, it should do the same thing, but still. It's almost like it's doing something else. Okay. What? Chat, I am getting some weird ass shapes here. Oh my God. It's not off by 180, Gary. It's off by 90 and negated. What? Imagine using multi-cursor without monospace font. Yes? Unbelievable. Well, it's unbelievable. You followed me. Thank you. Okay. It's not off by 180. It's off by 90 and negated. What does that mean? Why is this off by 180 in the first place? Let's ask ourselves that. Why is this off by exactly 180 degrees? Why is my rotation point? Why is it even not? Chat, don't tell me. What if it's actually correct? It's just not rotating around the rotation point correctly, and it's just rotating around like down here or something. What if that could happen? What if the rectangle is actually in the correct place it should be? It's just fucked off and rotated not around the rotation point. Should you do the same thing you did in Render My Point? Switch cosine, sine? Well, they yelled at me before when I touched it, but I guess I could try it. So instead of cosine, it's sine. Sine. Copy, paste, paste. Okay, you guys are gonna hate me for this, but just hear me out for a second. Let's make cosine sine and sine cosine. Let's see what happens. Nothing changes. Oh God. Why? Okay. What? How does that change nothing? Line 31, 32. No, this looks fine. Yeah, draw rotation point each frame instead of rotate collision rectangle. Did you pass the rotation point correctly to rotation function? Oh, that's a good question. So this is what we're passing through. Rotate collision rectangle. Oh, I guess I never gave it in. What? Oh no, I called this version of rotate collision rectangle. Which... What? Set collision angle. I'm sorry. This is what we called. So this is rotation point. Rotation point is the float point. Yeah, that is what changes. In fact, not only do we change it, right before the function is called for rotating it, we change the X and Y value of the rotation point. We do that to set the collision point. Basically set it in the middle of the image, which we know is correct because this point was successfully in the middle of the image. So this is perfect. Angle is correct. M collision is correct. M collision. Huh. Cosine angle equals sine angle. Sine angle equals negative sine angle? What? Oh, wait, what? Someone suggested writing text a couple of days ago, and now I agree. We need some tests to figure out the math errors. Yeah, I'm figuring out that I suck ass at trigonometry because I just don't know it. So you're saying negative cosine. I mean, yeah, we could try well, it would be... What did we do here? We did negative cosine. Okay, let's try that. Let's try negative cosine. Okay. Negative sine. Then it flips. What the fuck? Okay, so obviously this is correct, but we're missing. It needs to be reflected across the y-axis. That seems to be the issue here. So what if we switch the formulas? What if this applied to sine and sine applied to this? What if we just do that? What happens? Well, now it's 90 degrees off again. And negative sign just translates the box. Yeah, that looks about right. Okay, interesting. It's still not rotating around the, oh my God. I just realized. It's rotating. Look where it's rotating from. It's rotating around a corner of the rectangle instead of around the center. Is that the issue? Switch first, yes. Oh. Where do you call set rotation angle or something? Oh, hold on. So do switch them. Okay, well, let's switch them. And then instead of negative cosine, it's negative sine? No. Still have that issue. In fact, if we still do negative cosine, then we have that issue. Fuck. So now we're 45 degrees off again, but that shouldn't be the issue here, right? Is it 1 times this for whatever reason? And then this is -1? I mean, it's the same thing, obviously, but still. I want to try anything right now. Yeah. Where do you call set rotation angle? Well, set rotation angle gets called here. Never mind, doesn't get called there. It gets called set rotation angle. This? Rotation collision angle? Set collision angle is called here. But I don't have a set rotation angle. I mean, I guess that is what you're looking for. Okay, switch everything back, but do angle plus pi divided by 2. AKA pi divided by 2 minus angle. What? Set everything back? Okay, so now you're saying angle is equal to angle plus equals m pi divided by 2. I don't know what this would do, but all right. Yeah, I didn't do anything. Wait, no, that did do something. Oh, wait a second. That did do something. No, it didn't do anything. You have to negate angle as well? Anywhere else? Yeah, under the attack function, but we don't. We only create that at object start. We're not even rendering them. Or set collision angle. That's the only other time we ever touch it. Load game? Set collision box, but that doesn't matter. All it does is create the rectangle and make it equal to this box. Wait a second. Create rectangle. 0, 1. Yeah, we already talked about this. This is what we want. Try the Brownie Man thing. You have to negate angle as well. Angle equals pi divided by 2 minus angle. In the same thing? What do you mean, Brownie Man? Like immediately afterward or like right here? I'm just not sure about the when, you know? Minus equals m pi divided by 2. Instead of adding it, so subtract it? Well, still doesn't make a difference. Instead of adding it, just set it. Oh, like this? Oh my god, that worked. What the shit? Oh wait, somebody just followed. Was that Painting Day? I'm so sorry, I missed your name. I was so excited. Okay, hold on. Big development. Okay. So now it's not rotated at all, but at least it's centered. Okay, by the way, I don't know what you wrote. I'm not sure when I'm supposed to be implementing an angle change. M pi minus angle. Okay, just put it right there, I'm assuming. I'm not really sure where, why, or how we're doing this, but... Oh my god. The fuck? It's way the fuck up there. Does that mean here we have the negative cosine? Oh! Wait, now we have negative sign, and it should flip correctly. Oh, please work. Ah! Well, now we're backwards, interestingly. This is kind of backwards where we were before. It's almost like this is like recreating everything we just did, but like doing it immediately. The point should move. Well, right now I'm more worried about the initial rotation. Wait, why does the point move? The point should move? I mean, we could make it move, it's trivial, but I'm more interested in the rectangle right now than anything else. Actually, it's not supposed to move. Is rotate rectangle being called every frame? No, it is only once. If it was rotating every frame, it would be flipping out. What if we switch now that we have that? Maybe that was the answer here. Let's switch these. Boom, 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 boom. Sounds like my commissioned music. And then here, we're gonna have negative sign. Let's see what happens there. Oh! Closest we've gotten. Now, negative cosine's gonna make it go all cattywampus, huh? Yeah, it's not, yeah, okay. So what if we just do just sine and cosine? Okay, then it fucks off to Narnia. Okay, now just negative cosine. Makes it rotate, that's bad. But we are closer than we've ever gotten with this. That is the closest we've gotten. It is rotated, but it's almost there. If I could just get it to like rotate a little bit more. By the way, Gary, you can try to do my complex number thing. You might have to negate the call to STD polar though. Why not just angle equals minus angle? I don't know. Math is hard, bruh. So it is this fucking function. God, we spent so much time on this too. Okay. What if we add angle? What does that do? Okay, it fucks off over there, and then we negative cosine. Okay, now we're just all kinds of cattywampus. Back to fucking 45 degrees. Okay. What do we do here? It's almost like minus angle plus 45 or something. It's almost like something weird like that. Can you render rotation point? That is what this cross is here. In fact, this cross is here, and then this is like the velocity it's going at. So this is where the rotation point is facing. So that's what this little cross is here. That's the point it should be rotating around. Wow, I would go crazy with this font in my IDE. Ink free, size 10, bold. I need to have that shit in my like title because I get that question all the time. I think it's cute. If I could have cursive chat, I would be so happy. Hold on. I can fix this. There must be a cursive font, right? Right. There must be. There has to be. C++. There must be. Modern script. Oh, no. Well, actually, that is cursive. I'm thinking about it. Roman, Simsun. Okay, so script might be cursive. Himalaya. Nah, we'll stick with ink free for now. Oh, show us the set collision something. You set rotation point to something else there, I think. Set collision angle. It's this. Rotation point is equal to the M render thing. So this basically sets the rotation point to be the center of the angle. However, surprise, surprise, we only call it once. At object creation, actually, which is why we call it outside of the loop here. We set the velocity, we set the angle, which uses the velocity, so 30 degrees. And that, well, in SDL's case, 330 degrees. And then collision angle, which should also set the rectangle to 330 degrees based on the angle. Because it uses that input. It uses the updated rotation points. And it uses M collision, which is the rectangle that we're changing. The render box doesn't matter because it sets it. Does it matter? When does the render box get updated? When we move it? I'm gonna, hold on. I know I shouldn't do this, and I know we're gonna make a giant circle, but just real quick, what if we call it after moving it? Okay, I mean, why is the rotation point there? Oh, that's weird. Hold your horses. Why is the rotation point there? That's not right. What's going on there, Chief? Interesting. Why is that rotating not on the rotation point? You set the rotation point elsewhere that fuck everything up, probably? Interesting. So maybe I shouldn't update it here? What does that do? Oh, there it goes. Off into Narnia. Okay, so that is, it does follow that. But it should be in the middle of the image. Why is it in the fucking nowhere zone? This is the rotation point. That cross is that point. That is what we are rendering, is that cross there. But why is it rotating here? Doesn't that imply that the rotation point here is like doing something weird? You set the rotation point elsewhere that fuck everything up, probably. Move those two lines into a constructor. What two lines? Well, specifically, what am I moving into a constructor? I don't get it. If the rotate function isn't being called every frame, how is this happening? Well, now it is. We just created it, Sassy Vegeta. We just moved this function to be called every frame. That's why the rotation point here on the bullet in the center of it, this cross is moving now, because now it's getting updated every frame. But what's weird is that the rectangle isn't rotating around the rotation point. It's just fucking doing its own thing. It's like a goddamn helicopter. Although, chat, I will say, I just made a sick helicopter base. Those two lines you set rotation point. Oh, okay. So this, you're saying, move those two lines into the constructor? Here? What do you mean by that, Chief? Give your constructor line 15 new lines? Why? Why do I want them to be part of the constructor? We're updating in every frame anyway. Fucking ultra wide screen. Like, I get it. Okay, you want me to add it to this. I understand that, but why? What I don't oh, you mean just give it new lines. I'm sorry, English, please. There, like that. So M render rect, input sprite size, M sprite, rotation point. That's the rotation point. Inside of the brackets. Oh. So you mean like... Oh, you mean just move this in here? Like that? Is that what you're looking for? Yay? Nay? I don't know what that difference that would make. It's the exact same thing, except it's only updated at... Oh, and there it's fucking off because we're not updating it. Well, because we're not calling... Hold on, let me delete that. Because we're not calling it every frame now. And we wouldn't anyway. So now we have the issue where it's not rotated at all. Why? Where else do you update the rotation point? Basically, what I do is I update the rotation point to be updated immediately before we need it in the rotate collision rectangle. But now we don't have any rotation at all. Chat, this fucking rotating rectangle. Oh my god, we spent so many hours on this now. C++ is an interesting choice to learn. Are you coming from another language? Not really, no. I feel like learning game development without learning C++ is like saying you want to go to the gym without doing a leg day. It's like, yeah, nobody likes to do it. Nobody likes memorizing the opening moves in chess and shit, but you have to do it if you want to be good at it. IMO. Can you actually render rotation point inside of the rotate function, please? Okay, hold on. Bunch of people are wanting different things right now. Here's why we're not going to do any of it. First of all, this point here, this is your rotation point. So we are rendering it, okay? It's where the initial rectangle should be rotating around. If you want it to follow the bullet, I can do that, but that means we have to call the rotation thing every... Would it feel better if I just made a function that's like move the point and we just call that every frame? Keep the shit inside the constructor. I would rather solve the rotating rectangle first, and then we worry about making it look better. We did render it in the plus in the middle, yes. Also, Griffork, thank you. Hi. Hello, hello. So, I mean, can we try the complex num thing? What? Wait, what is, hold on, chat. Before we do anything, let's solve this one step at a time, okay? First things first, let's rotate this. So now it's rotated. Now let's make it rotate correctly. Let's put it on the bullet. Then we can worry about anything else, okay? So, what are we doing here? Why, hold on, was it Brownie Man? Why did we add the angle or subtract the angle here? What is the point of this? Also, this should be just minus equals. Oops, with a semicolon. No, that isn't minus equals. What the shit? What's the difference? Oh, it's angle minus pi 2. Okay, I see what I did there. So what if I did plus angle? Well, that doesn't make a difference. That's gonna fuck off into nowhere. Yeah. It's almost like this plus like 45 degrees. That doesn't do anything. I don't know, something's weird here where it's just not rotating all the way. Here's the thing, the center of the rectangle is moving. Think about what that means. It doesn't mean anything. We only rotate once at bullet creation. That is the only time we ever, oops. That is the only time we ever do anything right there. That initial rotation of where the thin rectangle is, it should be around the bullet because it rotated around that point, that cross. That's the only time that matters. It doesn't have to follow it because we're not rotating in flight. It's not like a boomerang or anything. So that's the only thing I care about right now. I just want to rotate. Once we get the rectangle matched onto the bullet, we can do weird shit, but I just need to get that correctly. Comment out the move. We need to isolate the thing. Okay. Oh, that's scrub. Hold on. This. Here. So there we go. So that's where that's being rotated. So you could see it is now, hopefully, correctly rotating around this point. Right? Does that make sense now? Yeah, but the center of the rectangle is now on the side of the bullet and not in the center. Is it? Negating the angle makes it go clockwise, adding to it shifts its initial point. Negating the angle makes it go clockwise, adding to it shifts its initial point. So we have an issue where we give the input of 45 degrees, SDL flips it to 270 degrees, but the way we programmed our rectangle goes to 210 degrees. So how do we add, how do we fill the difference of 60 degrees somewhere? It's almost like it's like a reflection issue somewhere. It's not a rotation point Y, rotation point X thing. That's correct, right? It was before you commented out move. Well, that sounds like a translate issue, but we're not even calling this anymore. Gary, there's an easy way to fix this. Go to the render function of bullet. Okay, here. Oh! What if we do that? Nope, that doesn't work. Go to render my point, switch it back and remove the minus. Render my point here. Render, oh, I'm assuming you mean this. Switch it back. Remove the minus. Okay. That seemed to have solved nothing. Minus angle, minus angle. What minus angle? What? You mean this? Or this? I'm a little confused what you mean here. In render, okay, go to render my point, which is this function. Switch it back and remove the minus. Minus angle. Oh my god, minus angle in render. Okay, so now we're in render. I don't know what you mean here. Oh my god, you subscribed on YouTube. Sorry, guys, I'm gonna be honest, I don't know how to fix that alert. So if you subscribe on YouTube, you get way more attention than what you probably bargained for. Thank you. Why the fuck I told you to go to render to muck around? I don't know. You told me to go to render. Hold on, I'm gonna repeat your, hold on, not to call anyone out here. I'm gonna repeat your directions exactly. Can you switch sine and cosine to be back to normal so we are only dealing with angle? Minus angle. Okay, go to render my point, switch it back, and remove the minus. Minus angle. OMFG. Minus angle. In render. Why the fuck I told you to go to render to muck around? I told you to go to render and you muck around null pointer. I didn't told you to muck around with null pointer. Okay, I don't know what you want me to muck around with. You told me to go to render. We are at render. Go. Minus angle. Here? Is that possible? Muck. Is this what we wanted, chat? Is this our life? Oh my God, it's not even like perfectly rotated either. Cause look, it's like offset by like 1 degree. That's weird. I only have a pet peeve with all of, wait, stop. Ah! Hold on, everybody shut the fuck up. Ah! No, we're so close. Ah! Oh my God! Please be it, please be it. Fuck! It's the same problem. Okay, well, fuck me. Sorry, I got excited. Swap it back, line 32, 34. Okay, I'm assuming you mean... I guess I was wrong then, swap it back. I just did it, right? It's sine for cosine. Oh, wait, why are those backwards? No, that is backwards. Hold on, this is what we want. Yes, that is what we want. We just have minus angle on the render. Wait. Chat, do you think the problem is we changed angle to be radians? And angle of renderer expects a double, which implies a degree? No, that wouldn't matter. It would be the same thing. Not gonna lie, this is a really cool of a stream. Well, thank you, Portuguese. What if I told you my family was Portuguese? Are you from Brazil or Portuguesa? Don't make them backwards. I don't think so. We should be able to fix by changing phase and sign. Riftfork? No. Hey, yo, I'm from Portugal. Ooh, my family is from the Azure Islands. I'm from Brazil. Crisinho! Crisinho. Hello. I got Brazilian friends. Her name is Mila. She's a slime VTuber. She made fun of me when I said my favorite breakfast sausage is kielbasa and eggs, and she laughed at me and she said all kielbasa is sausage. And I thought, I felt really stupid, but hey, that's life. I'm still not sure we should be switching sine and cosine. That seems wrong to me. Well, chat, you have to understand. Right now, I am in like, let's get the rectangle to match up mode and then worry about like all of the syntax, all of that shit, okay? That's what I care about. Is it like an issue where... I don't understand. I can't get it. I can't get this rectangle to rotate the same way the rendered rectangle. Should I just look at the library for this? Hold on. How do I look at the documentation? Was it F12? Okay, what do you do here? Okay, that's the center point of rotation. That is the double angle. Renders a list of triangles, optionally using a texture, which we do, and indices into the vertex array color, and alpha modulation is done per vertex. Color mod, yeah. Parameter indexes optional, an array of integer indexes into the vertices array, so you can make like vertexes optional. Render geometry. Oh wait, no, that's render geometry. This function has been available since then. Huh. Okay, so this is what we want. A pointer to a point, an angle in degrees. Oh! Is the problem here, chat, is because we set angle to the inverse tangent, 180 divided by pi, does that imply that we're changing that into not degrees? Should we do something like angle is equal to m pi divided by 180? Does that matter at all? I mean, it doesn't help. Portuguese. Oh, I like those shapes. Cute. It's been 15 years since I did what you did, trying so hard to remember how to do math without matrices. Swapping sine and cosine is the same as negating angle sign and applying a phase shift. What's a phase shift? Silkqueen Butterfly, long time no see. I see you lurking there. We know those parts works. We did uni test on them. Oh, we did. You're right. Based. This part's fucked up though. Something about this is weird. Okay, I get it. This is worse, right? Well, not necessarily. It's pointing the right way. Oh, Chad, I don't get it. What's fucked up about this? Why is it 60 degrees off? What a weird number to be off by. Why is it off by 60 degrees? Why would it be off by 60 degrees? That implies that the X and Y value are negative and positive. Wait. -1 times. We didn't do this recently. We tried this before. Oh my God, I just did it. Holy shit, that was the most complicated. Chat, we spent like 9 hours on this shit. Oh, that is so complicated. I have no idea why that worked now. I think it was Brownie Man. Well, what's up? It was MVP. Brownie Man was MVP +1. Oh my goodness. Alvaro 2K7. Please don't tell me you were born in 2007. That would make me feel so goddamn old, because that means you're old enough to graduate high school next year. Oh, why would we want pi divided by 2? That's a 90-degree shift. This is not right. You just negate y. Now change the rotation and make sure it still works. Oh, okay. Chat, I swear to Christ, okay? If I change this by 60 degrees, so instead of going 1.5, let's go 0.51. If it goes in the opposite direction, I am ending the stream right now, by the way. Oh! Chat, I don't give a shit how bad my programming is. We have successfully made a rectangle, translated it, rotated it around the point, and it matches the rendered rectangle. Holy shit. And I am very aware that there's some rounding issues and that the bullet doesn't perfectly align with the side of the bullet. It's like 1 degree off. That's fine. It's a rounding error. It's okay. Holy shit, that was complicated. No wonder people say making your own game engine is hard as shit. Uncomment the move, see if it works. Oh, it'll work. Oh, it'll work. Watch this. Boom. In my defense, okay, I had hope. Why is that being translated incorrectly? So now we have a translation issue. So this function is being called because all we do, the only difference here is that we set position change the rendered spot of the rectangle, and then translate. So we rotate first, that happens outside of the loop, then we move it every frame, and clearly that's moving this. So we are translating it incorrectly. So now we have a this issue. No, the translation is good. Is it? Okay. I mean, I'll trust ya, but are we sure? That function is good. Oh, wow. What does move do? Okay, so all move does, we do this once per frame, is we make two floats, position X and position Y. The position X is equal to the current spot of where the rendered rectangle starts, its top left corner, the 0 spot. The position Y is the top left 0 spot of the rendered rectangle. Then we add position X with velocity X and Y with velocity Y. So we're taking this value, adding it with velocity X, it's equal to the position X. Then we set position with those two values. Set position makes it so that the new rendered rectangle X is equal to this value. This is a glorified way of saying this value is equal to this value plus equals velocity X. That's probably what I should have done in just one line, but whatever. You guys get my logic here, right? Line 39 is the problem? Why is this the problem? A 26556753278. Thank you for following. I appreciate it. Your name reminds me of an old movie from the 70s. That is very good. You need to offset that to the last collision? What? Like plus equals? That didn't work. So what? This is what I want to update with this value. This does in fact load a standard array template float 8 that is the same thing as collision. What's the issue here? You need to offset it to the last condition. You move mRenderRectX by the offset. You should move mCollision by an offset delta. Oh, so you're saying that mCollision.x should be equal to plus equal to. Oh, you're right. I need to update the collision box. Except it's not .x. No, that's what we do. No. That is what we do. Because the sprite, this is that function. We also ask for the new x and y value, which is these two values. We already updated in the function. And then we make two deltas. Yeah, this is already accounting for the deltas, isn't it? Delta x equals bullet position x minus render rect x. Set it before you equal to each other. What? Grant Fork is following. Your name sounds familiar. Have you followed me before? Hi, thank you. Or maybe you were in chat a lot. I have seen you in chat a lot. I guess I just thought you were following already. Hello, thank you. I agree with the previous person. This stream is fun. I'm glad you guys find it fun because I'm gonna be honest, chat. This is fun for me. Thank you for this wonderful experience. Everybody hates on C++, and I get it, but like, the only trouble I ever have with C++ is not with syntax. It's not with like, I'm not fighting the language. I'm fighting my own dumbassery. That's what it feels like. It feels like my lack of knowledge of trigonometry is like biting me in the ass, but it's not like I'm like, it's not like I don't know what a struct is. C++ sucks when trying to use templates and generics. Templates like standard array. I guess I haven't made a template before, so maybe that doesn't count, but don't worry. After you grow out of C++, we'll be keeping a seat for you in Python. Python! Pwah! I spit on that chat. Pwah! Get that Python crap out of my face. Ugh, disgusting. Imagine saying, I'm gonna cook a food like Gordon Ramsay, and then you microwave your pasta. That's what Python is. You are the microwave of programming languages. C++ is going outside, making a campfire, recreating a stone oven, and then making pizza in it with ingredients you grew out of your own backyard. Don't worry, after you grow out of C++, we'll be keeping you a C for Python. Disgusting. Europa Universalis 4 and 5's usage of it makes it worse. Yeah, Unreal Engine. There you go. Do you call translate collision rectangle anywhere else? Yes. So we translate whenever we call, boop, 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 whenever we call move, and whenever we do an attack, which obviously we're not calling anything right now for it, but that's an example of how we would do that. We would call it separately position X and position Y. The reason being is that we want to store the X and Y value of that rendered rectangle. So that way when we shoot off a nova, every bullet in our temporary bullet vector, at the end of the frame, it renders all the bullets at once, each having their own rendered rectangle. I just bit my tongue and translated rectangle for the collision. And then it shoots off all in a nova. That's the idea anyway, but we're not calling it anywhere else. I mean, Python is good for winging stuff, but C++ is good for getting stuff done solidly. Correct. Python is microwave brownie and it is delicious. Python can Python my dick. New collision X is equal to M collision X plus delta X. No, that's already in the translate function though, isn't it? Delta is equal to new X, which is position X, minus the old rectangle, and that's the change, and then you apply the change to the rectangle. This is what you're describing, isn't it? No, it's different. Is it? Hold on. I'm not doing this to call you out, I'm doing it to compare. So new collision X, which is delta X, is equal to M collision X, which is 0, plus delta X. Wait, so it's a different delta. Delta X is equal to bullet position X minus render rect X. Set it before you equal to each other. That is exactly this line here. Oops, wrong one. Where are you, chat? There you go. So you just described this line here. Then new collision X, which is this, is equal to delta plus itself. But no, it's not. This is a different issue. I wrote the fucking translate function. I would know what it does. I'm just saying. And no, the language does UI better than TypeScript. Excuse me. Times New Roman, bitch. Put that shit in anything, you got a good UI. Actually, that's not true. I was about to say Comic Sans, but that's too much of a meme. Ink free. There you go. You don't want to translate the M collision to the position of the bullet because bullet position is not centered. Okay. So you're saying that we should have a new... In other words, you're telling me you want to change the values of M collision so that when we go into the translate, it has more accurate numbers to work with, and then we set it equal to this new value. Okay. So you're saying that float delta X is equal to bullet position, bullet position X minus M render rect dot X Isn't this 0? Unless you're saying this goes before then. It must be go before then. That wouldn't make sense otherwise. And then do the same thing with Y. Y. So then we make it equal to M collision. No, God, it's an 8 value thing. Oh my dear. What am I doing here? Bullet position X minus X. Collision X is equal to X plus delta. Translate. M collision 0 plus X, M collision 0 plus Y. So instead of bullet position X, it's M collision underscore dot X dot X. No, dot X. Thank you, Visual Studio. Plus delta X. Is this really what you guys want me to do here? Seems like a lot. Also, this is not X. This is array 0. Sorry. Oh, and then M collision 1 plus delta Y. What? No shot this is gonna be the answer. I don't believe you. I don't believe this for a goddamn second. What? How do you do this shit? You people are like magicians. What the fuck? How did you do that? What does that even mean? Okay, float delta. Float delta. You get the difference of where the render box comes from and where it's going to, and that's the change. You then translate with the X and Y value of where you're going. Why would you add them? Why didn't it just be delta? Oh, it's your new X value. Oh, you're applying the change to the rect. Well, why can't you just use the render rect? Oh my God, I'm so fucking stupid. You don't use render rectangle because, oh, I'm so dumb. You don't do that because the rendered rectangle is not necessarily where the collision box is gonna be, especially when we resize this shit, by the way. Okay, I get it. Thank you. Eat your words, Gary. Tastes disgustingly wrong. Why would I use something that disables 40% of the language? Oh. It's called complicating JavaScript with TypeScript compilers? Holy shit, people talking mad shit to each other. We all know the king C++ chat. You don't need to bow to us too hard, all right? Okay. Oh my God, we're done with fucking rectangles. Okay, I know we have a resize function, and I kind of just want to do it to see how wrong this shit is. I don't even want to fuck with it. I don't even want to touch it, okay? I don't even want to touch it, all right? We're not even gonna fuck it, okay? Forget it, okay? We're not resizing shit for now. For now, we'll come back to it later. Okay, chat, we're out of time today. Here's what we're gonna do. Tomorrow, try to Nova it. Oh, baby, I can do that for you right now. Okay, we'll turn them back to normal size. Okay. We're gonna delete all of this. No, delete these. Delete these. Delete our test rectangle. Delete our test rectangle. Delete our rot point. Delete our SCDC out. Delete our test rect. Delete our render angle. Delete our... No, keep our scrub. Now we spawn an attack, which is here. Okay, if everything works out, we should have Novas. Let's see. Okay, in my defense, chat, in my defense, that is not my fault, okay? let's shoot 100 bullets. And then we're also going to give it velocity now because Jesus Christ. Here. Uh-oh. Why aren't the bullets moving? Set oh, because I set the velocity earlier. Right. Where is that? That is... Where are we setting the velocity at? Call the attack. Set velocity. No, that's enemies. Where did I set my, set my velocity at, chat? Oh my god! We don't have velocity! Wait. Where's my velocity? Set velocity. This is the same. Where the fuck is my bullet? Oh, wait, we don't call move. Hold on, sorry. L bullet dot move. Okay, there we go. Now we go. Oh, shit. Oh, wait, no, they're wrong. Wait, something's wrong. Hold on. Something's wrong. They're not rotated correctly. Hold on. So the collision box is moving, but it's not moving correctly. Something is wrong in call attack. Yes. It is wrong. Look at this. Look at this. Look at... Oh, that's weird. Every other bullet is sort of correct. No, wait. The hitbox is moving every degree. How the fuck does that work? Gary, why did you make the collision boxes the same color? Oh, I can fix that if that makes you feel better. Or not feel better. I mean, I didn't mean that rudely, but like I can fix that right now. So, set render draw color. We'll go RGB. So we'll go blue boxes. There you go. So look at that. Look at how the bullets alternate. Every shot, it goes vertical, horizontal. Isn't that weird? It's like horizontal, vertical, horizontal, vertical, horizontal, vertical. And as you round out to the bottom, it rotates. Isn't that weird? So it is a problem with the call attack, right? Because we successfully rotated the bullet on our own. New difficult mode? Oh god. Although chat, did we ever test, hold on, remind me. Did we test a bullet by rotating its box? When we had the individual bullet render, did we ever test like switching it from, oh no, we did. Because it went from 30 degrees to like 60 degrees and it worked. And then we moved it and then it worked. So now we have an issue with this where the call attack function is fucking up. Okay. Okay, chat, I am done with rectangles. That is it for today, okay? This is all you people are gonna get today. You got spoiled, all right? It was a long stream. So here's what we're gonna do. Tomorrow, we're gonna fix the attack call. Once the attack call is done, I swear to Christ, we are doing scrolling backgrounds, okay? Because once we're done with scrolling backgrounds, and once we're done with calling attacks, and once we're done with audio, well, and bullets from the hero, and doing a collision box, but that's easy. We're just doing point and rect. I'm not even gonna make it complicated. Once we can kill enemies, and once enemies can hit us, and once we have a scrolling background, and once we have audio, we're ready to actually design the fucking video game. We'll get there, chat. We'll get there. Oh, baby. Everybody, come here. Give me kisses. I'm like your grandma. Give me kisses. All right, what are you doing up there, chat? Why are you trying to hide from me always? Come here. All right, everyone, have a good night. Have a good evening. Give me kisses. Bye. See ya. Bye. I can't get my cute eyebrows and my tongue in there. Hold on.